So hi guys, my name is Erlyn Joy Fernandez. I'm a level 6 creative computing student and my student number is 480561. And today I will be doing a video walkthrough for my machine learning model. So let's start. So what I did first is I've imported the required libraries. These are OS, Matplotlib, TensorFlow, IPython, and warnings to ignore all the warnings for my machine learning model. So second, I built the data loading function and created visualization. So I um, declared and load the data set that I've used using OS, and then define the paths for my files, which are Capuchin bird file and non-Capuchin bird file. And then I've decided to um, use the IPD to allow the machine learning to play the audio. So that's the example of a Capuchin bird call from Capuchin bird file. And this is the example of non-Capuchin bird file. Then I also created this function to load and decode my audio files. Then I also I wanted to create a visualization of the sound wave of a Capuchin and non-Capuchin file. So these are I only define um, the visualization using CB wave and NB wave for non-bird wave example. So this is the plot. And then I also created a TensorFlow dataset. So I defined the paths for this using OS. And I also use TensorFlow to create the dataset. So positive and negative. Positive are for those files that contains Capuchin bird calls, and negative for non-Capuchin bird calls. So this is how I added labels and how I combine the positive and negative sample using the zip from TensorFlow. I also define the data here using the positive samples and the negative samples. Then next, I determine the average length of a Capuchin call using this loop. So I also use the TensorFlow to check the mean of an array, and I divided it to 16000, which is the hertz that we've used earlier in here. See? So this is to get the mean in seconds. So I also use the same for min and max. Okay, so then I used a preprocessor function for creating and converting the file into a spectrogram. So this is the preprocessor function. So as you can see, I also used matplotlib directories here in order to create this plot. And this plot is the spectrogram for Capuchin bird file, while this plot are for the non-Capuchin bird file. And then next, I created the training and the testing sets. So what I did here is I created the data pipeline using TensorFlow, and then I split the data into training and testing sets. And then I also test one batch using and I also use the numpy iterator and the next function so that I can the model can get the next example out of the sample data. Then I also get here the sample shape, and then I also built and trained the deep learning model. So I imported here the TensorFlow libraries for sequential and the layers. So I also build the sequential model, compile, and view the summary over here. So as you can see, this is the summary, the sequential model summary, and I did this using the summary function. Then next, I created the training history and trained the model using 4 epochs, and then print the the model's loss in using the matplotlib. I also use the matplotlib to print out the model's accuracy and get the evaluation using the evaluate function. And then in here, I just printed out the model's loss so that we can see it in numbers as well as the accuracy. Then I also made a prediction using a single clip. So I just defined the X and Y test values here, as well as get the shape and the Y test in order to know and see if they match. So based on this, they indeed matched. Then to predict the capuchin bird call, I define the y hat or the predicted value using sequential model predict function along with the x test. And then, so in here I just formatted the prediction. So yeah. And then I printed out the y hat value to see if it will match to our y test value. And based on this, it did match. Then 9, I built the forest parsing function. So I used this to, it is the same format using the decoding, the load decoding or the load function that that I used earlier. So in here, I just convert the WAV or the wave audio length value in here using the tensor. So I also loaded and defined the MP3 using OS again so that I can give the path. And then I also gave a new variable to our wave or WAV using the loading function along with the MP3. And then I also converted the file into audio slices. So I use TensorFlow to be able to slice the audio for here. And then this is the preprocessor function. I use to I define the sample using this array, and then I also used a filler so that if the audio length is large, then it will fill the steps with 0. So I also included here the spectrograms, and then I converted the audio slices into spectrograms. So to be able to use this, I also again use the TensorFlows. And then I proceeded to making predictions. Then to group consecutive detection, I again imported a new libraries, which is group by from intertools. So it allows the consecutive calls be read as a single call. So this is how I group the predicted values. So in here I also define the calls using this formula. Then I printed the calls here. So this is, and I also use again the IPD to play the file. So in here, this is 3 minutes long. So along these 3 minutes, we have 25 bird calls or capuchin bird calls made. So this is basically the result of it as well. So next, I just made the capuchin bird call predictions for the whole data set. So to do this, I made a result class which has a loop function to it, so that it can loop through every single recording from the forest recordings, which is the test data set. And then I included here as well the sliced audios, and the prediction format. So this is the class prediction as well. So in here we can see the results that the recording dash 76 MP3 has won, which means it has a bird call on it, and the 0 stands for um, non-capuchin bird call, and the 1 stands for there's a capuchin bird call throughout the recording. So this means that the first two, I mean, um, the 3 seconds, these are all 3 seconds each. So for 3 minutes, we have a lot of bird calls. So that's why it's included here that this audio file, in fact, have a bird call in it. So this is actually long for it tests out through all the audio files. And then lastly, we also have the post-process prediction class. So in here, I made it easier. I made this class much easier to read. So it will just show how many bird calls are there for each audio recording files. So that's it for my machine learning project.